All right, good day everyone. This is Dr. Yahya. I'll be taking PHY 403 Computational Physics this semester. In our first class, I introduced Python. I introduced the course, the recommended textbook, the course content, and I gave a brief overview of Python. So today we'll go straight to basics of Python. So we'll start with numbers, variables, comparisons, and logic. So these are the topics we'll treat today. So I expect that you have installed your Python. So to know if it is successfully installed, you can search for Spider, for example. It's a good editor for Python. Okay, so you open Spider. All right, then just type anything, maybe x equals 5 or 6, print x, just to be sure that print x. So this is 6. All right, so if you get this, so it means your Python is correctly installed. Okay, so Python can handle different types of numbers. Python can handle integers, 1, 8, minus 72, and so on, integers without decimal point. Python can also handle floating point numbers like 1.2, minus 0.36, and so on and so forth. So Python can handle all these types of numbers. In fact, Python can also handle complex numbers. So how does Python handle integers? For example, this x equals 6 is an integer. Okay, so and we have 6 here. If I type 6.5 or 6.6, so that is a floating point number. So 6.5 is floating point because it's decimal point. So Python can also handle that 6.5 here. Okay, Python can also handle complex numbers, maybe 2 plus 3j. Okay, 2 plus 3j, then you get that here. So this 2 is the real part of the number and 3 is the imaginary part, because if you say print x dot real, it will print 2.0, because if you have a complex number, the first one here is the real part, the one with I or j is the imaginary part. So if you type print x dot image, it means you want to print the imaginary part, which is 3.0. So the real part is 2, the imaginary part is 3. So Python can handle all these types of numbers, okay, from integers to floating point numbers to complex numbers. In fact, we'll get to that later, how to handle arrays. Okay, so I believe this is clear and straightforward. All right, so what are the basic arithmetic that we can carry out in Python? We can carry out all the basic arithmetic operations like addition, subtraction, multiplication, floating point division, integer division, modulus or remainder, exponentiation. Okay, what do we mean? So let me comment this out. If you want to comment in Python, you can do it in 2 ways. Number 1, you can use pound operator. Okay, so if you include pound operator at the end of the line, it will not print anything, so Python will not read that line. So the second way to comment is to use triple quotation signs. Okay, like this. So anything you write here, my name is Yahya. Okay, Python will not read it because it's a comment. So you can comment out a line using the pound symbol, or you can use this triple quote. So whether the single or double. Okay, all right, so let's start with addition. Okay, I've uploaded this material on the LMS. Okay, so you can read through this material on LMS. So this is the title. Okay, now let's start with addition, basic arithmetic operator addition. So we can say maybe x equals 5 and y equals 7. Then we say print, or let's say z equals x plus y. Okay, z equals x plus y, then print z. So if you want to output your result in Python, you use print. In some programming languages, it is write. Okay, so but in Python, it is print. So if you want to print your result, you say print z. So we are assigning this variable x. We are assigning 5 to this variable x. We are assigning 7 to variable y. It means any time Python sees y, Python should take it as 7. Okay, then z is the summation of x and y. So if you print z and you run, so this is where you run file, or press F5 on your keyboard, so you get 12, which is 7 plus 5. 7 plus 5. Okay, I believe that's clear. Alright, so that is addition. Or you can say print, you can format your print. You can say print the addition is then you put comma z. So you can format the addition is 12. What about subtraction? Okay, so let's use another variable for subtraction. Let's say m. So let's say m equals x minus y. Then we say print the subtraction is m. So that is, the result will be x minus y, or 5 minus 7. So and that should be minus 2. So we get that. So the addition is 12 and the subtraction is minus 2. Okay, what about the multiplication? Let's use q for multiplication. So q equals x star y. So if you want to multiply, if you want to add in Python, you use the plus symbol. If you want to subtract, you use this dash symbol. If you want to multiply, you use this star. So q equals x star y, means q equals x multiplied by y. Then you can say print again the multiplication is, then you say q. Okay, so multiplication is 35. That is 5 multiplied by 7 is 35. Okay, so I believe this is straightforward enough. What about division? We want to say 5 divided by 7. Now, there are two types of division in Python. Number one is this floating point division. Number two is integer division. Now, the regular division that we know, like 4 divided by 2 equals 2, 8 divided by 2 equals 4, 12 divided by 3 equals 4. So you use for division, let's use d, so equals x / y. Okay, x divided by y. So this is a symbol for division in Python. This is symbol for division. Okay, so we can say print the division is comma d. Division is d, and we run, and we get the division is 0.71 428571 and so on. Okay, so that's the division. So that is 5 divided by 7 is 0.714 and so on. Okay, so we have looked at addition. So this is addition. Let me use comment addition, and this is subtraction. Now I told you if you use pound sign, that is comment. So usually it is recommended for you to use comment anytime you are writing your code, so that maybe the next 1, 2, 3 years, if you get back to the code, you will know what the code is actually trying to calculate. Okay, so and this is multiplication. So you just put pound sign, then everything. So Python will ignore anything after the pound sign. So multiplication, and this is division. That is a floating point division. Okay, all right. So we have looked at addition, subtraction, multiplication, floating point division. So we are left with integer division, modulus, and exponentiation. Now, what is the integer division? So integer. So let me say comments. Integer division. So in integer division, if you say 9 divided by 2, 9 divided by 2 you have 4 remaining 1. So if you use the integer division, the symbol, what you do is double /. So it will return only 4. Okay, so if you say print 9//2, so the answer will be 2. The answer will be 4. It will ignore the remainder, which is 1. Okay, even if you type 11 //2, which is the integer division of 11 by 2, the answer will be 5. It will ignore the remainder. It will ignore the remainder. Okay, so this is useful in certain numerical calculations. Okay, so you may want to test if the number is maybe divisible by 2 or not. Okay, so if the number is divisible by 2 or not, so on. Then this is integer division. What about the modulus, the remainder? Remainder. So for that we use the percent sign. Okay, so now if you say print 11% 2, print 11% 2, it will print 1. You know, 11 integer division by 2 gives 5. So if you want to get that remainder, which is 1, so you use the remainder, the percent sign. So 11% 2 is 5, remainder 1. So this will give the remainder. You can also try maybe 13 29% 3. So that is 29 divided by 3. So the remainder is 2, because 27 9 times 3 is 27. So that is 9 remainder 2. Okay. So this percent sign is for the remainder of the division. If it is like 27 divided by 3, the remainder will be 0, because 27 divided by 3 there is no remainder. Okay, it's just 9. So no remainder, so it will be 0. Okay, so I believe that is clear enough. Okay, now I think let me take let me take an example. Okay, let me talk about this before the example. Operator precedence in Python. Okay, so I've not talked about exponentiation, sorry. I've talked about modulus. Okay, so it remains exponentiation, which is double star. So the exponentiation means like you want to calculate 2 raised power 4 or 10 raised power 8 or 3 raised power 9. Okay, something like this. Okay, yeah, something like this. That you want to evaluate y equals 4 raised to the power of 3. That is 4 times 4 times 4. So how do you do that in Python? So what you do is say y equals 4 star 3. Okay, so the next one is the exponentiation. Okay, which is star. So if you say 4 star 3, then you say print y. So it will print the 64, because 4 raised to the power 3 means 4 times 4, which is 16, multiplied by 4, which is 64. Okay, so that is exponentiation. So I think we have covered the addition, subtraction, multiplication, floating point division, integer division, the modulus or remainder, then exponentiation. Now, you must be careful when you use these operators. You must note that the exponentiation takes the highest precedence, followed by the multiplication and division. Okay, then the addition and subtraction, they take the lowest precedence. Now, you must be careful when you are using Python to do calculations, because if you type 6 divided by 2 divided by 4, it's different from 6 divided by open bracket 2 divided by 4. And you know, computer is garbage in, garbage out. So if this is what you mean and you are typing this, you'll be getting wrong answer. Okay, so that is why it is advisable to use the parenthesis, the bracket. Okay, so the same thing, 2 star 2 star 3 is 256, but 2 raised to the power 2, then the result raised to the power 3 is what? Is 64. So you must know what you want to calculate. Then you use the parentheses appropriately. Okay, so I will strongly advise you to make use of the parentheses. I will strongly advise that. So anytime there is many of the operators in the same line, so it's advisable that you use parentheses so that you tell the computer what you actually mean. All right. All right, so next is mathematical functions. Now in Python there are many mathematical functions under the math module. Okay, now if you just type maybe x equals sine 2, there will be an error. Can you see? So the advantage of using, I didn't state it earlier, the advantage of using Spider as your text editor for writing Python codes is that it will tell you where there is an error, okay, or there is a warning. So for example, here we say x equals sine 2, and so there's a warning here that's undefined name sine, S-I-N. So because we have not, Python, pure Python does not recognize this SIN symbol. So if you want to use the SIN symbol, you import it from math. So you can say from math import SIN. Okay, from math import SIN. So even though in applications, in research, we don't use the math module, we do not import sine from the math module. Usually we import all the functions from NumPy. Okay, from NumPy, but we'll get to that shortly. So x equals sine 2. So now Python will recognize it. So there are many functions, built-in functions in the math module. So but you have to first import those functions. Okay, so there are many ways that you can import the function. This is the first way. The second way is to say because if you need cos, again you have to import cos. If you need tan, you have to import tan. If you need square root, you have to import square root, and so on and so forth. So you have to import all the functions that you want. This is one way. The second way, so import 1. The second way to import import 2. This import 2 is not recommended. Is that you say from math import all. That is to import all the functions in math, and you can continue to use all the functions. Okay, so you can say t equals square root of 25. Okay, then you say print t. So all the functions, they are already imported. But this is not good. Why? Because when you are writing a long code, usually you import some from math, you import some from NumPy, you import some from SciPy. Okay, so this is not usually recommended. Okay, so the best approach is to import 3 is to say import math, maybe as MP. So anytime you need a function, then you say MP dot. Okay, for example, you need cos, so you say C equals MP dot cos, then maybe cos 3, then you say print C. So this is the recommended way to import. Okay, because you know where you are getting your cos from. Your cos is from math module MP. Okay, so this is the best way to import, or you can just use this method. This method is also good. So you import only the functions that you need, so to save memory. So if you are writing your code, you can use this method of import, the first one, or the third one. The second one is not recommended because there can be conflicts and it may affect your results, your codes. Okay, so use either the first method or the third method of importing. Exactly. Okay, so there are many functions that you can import. SQRT for square root, exp for the exponential, log, log for the natural logarithm. So please, you should take note, log is for natural logarithm. Okay, if you need logarithm to base 10, then you say log 10 for logarithm to base 10. Okay, then if you need logarithm to its particular base that is different from base 10, then you say log into brackets the number, comma the base. So maybe base 2, you put 2, maybe base 8. Okay, so this b will be the base. So sine, cos, tan, arc sine, that is ASIN, arc cos, ACOS, arc tan, sine, cos, tan, arc sine. So all these functions, the factorial, error function, gamma, degrees, that's to convert a number from radians to degrees, then to convert a number from degrees to radians. So all these are in the math module. They are also in the NumPy, in the NumPy module. Okay, pi. So you can import pi, pi. So if you need pi, if you need this e, so you import math.e. Okay, they are all in the math module. Now, when you are, we have been using variables. This c is a variable, t is a variable, x is a variable, y is a variable, d is a variable, because we are assigning some numbers to them. Now, you can use any name as the variable name, except all these that are called reserved words. So you can use any name as a variable name except these reserved words, and then finally not. So all these must not be used as variable names. So they are reserved words because they are they have a meaning in Python. So there's special functions in Python. Okay, like if you want to create a function, you use def. Okay, so you want to import from maybe a particular module, maybe math module. We have imported from math module, so and so on. So all these must not be used as variable names. So it is highly not recommended to use them as variable. So you can use any other. You can use your name. Okay. So here you can say Shola Beru equals 5 raised power 4. So print Shola Beru. So you can use any name. Okay, but do not use the reserved words. Do not use the reserved words. All right. So let's take a simple example. So the example is, so let me try to open the spider. Example. So example 1. So this is the example. So the example says, given that y of t equals v naught t minus half gt squared, so that we should find y of t when t equals 0.5 seconds, g equals 9.8 meters per second squared, and v naught equals 10 meters per second squared. So what you do, so you want to evaluate y. Okay, you want to write this formula, and you are told that t equals 0.5. So the first thing for you to do is to write the variables. Okay, so t is said to have to be 0.5 seconds, and g is 9.8, and v naught is 10 meters per second. Okay, then you now say your function y equals v naught t. Now v naught t, it must be v naught times t. Okay, if you just write v naught t, Spider will give you a warning here that v naught t may be undefined or defined from. Okay, so it must be v naught multiplied by t, then minus 1/2. That 1/2 I strongly recommend that you put it in brackets. 1/2 multiplied by g, so g, then multiplied by t squared, so t squared. Raised power. Okay, it's star exponentiation. Okay, star. And so you now say print print y. So print, you can say the result is y. The result is y. So and the result should be 3.7. So 3.775. So that is it. Okay, you can even put units. You can write it like this. There is no problem. But since this is a physics, computational physics, you can say meters. Okay, so this print, what we have in these quotes, these quotation marks, so they are like string. Okay, so this is a string. So Python will just print this string, then the number y is a variable, then another string. Okay, so 3.775 meters. So this is better. Okay, now I think I need to mention about string before I move on. Strings. So string, so if you just write tire, if you just say print tire, there will be an error. Okay, Python already told you that tire may be undefined. Okay, but if you really want to print tire, then you have to put tire in quotes as a string. So Python will recognize this, that tire is a string. Okay, so string, so Python will print tire. Okay, I want to see if I can expand this anyway. Okay, so print tire, so Python will recognize that as a string. Okay, so but if you just say print tire, Python will look at, is this a string or a number? Okay, so if you just run this without putting the string, there will be an error. Name tire is not defined. Name error. Okay, so anytime you get this name error, so it means you have not defined a name. So we don't know whether it is a variable or a string. So but if you define it earlier that tire equals 2045, if you print tire, then there will be no problem, because tire is what, 45. But sometimes you want to print a string, like what we did here, that the result is, we want it to print that, so you put it in quotes. So print tire. Usually when you start learning programming, the first thing you print is hello world. Okay, hello world. So print hello world. So it must be in string. If it is not in string, then it must be a variable, and you must have assigned a number to the variable. So I believe that's clear. Okay, another simple example is they said the formula for converting temperature measured in Celsius degrees to the corresponding value in Fahrenheit degrees is F equals 9/5 C plus 32. So calculate the temperature in degree Fahrenheit. So there should be R here, FAHREN. When the temperature in degrees Celsius is 21 degrees Celsius. So we want to convert. This is a formula to convert degrees Celsius to Fahrenheit. So they now want you to write a code for this function. So let me call it example 2. Example 2. Okay. So in this example 2, you are told that C is 21. So C equals 21 degrees Celsius. So your formula is F equals 9/5. So put that 9/5 in brackets. Then multiply by C. Then plus 32. So you can now say print the temperature in Fahrenheit is then F. So then if you print that, you have the temperature in Fahrenheit is 69.8. Okay, so, and I think that is the answer that we got here as well. Okay, so that is the example 2. So it's very, very simple. So just 9/5, put 9/5 in brackets. Okay, then multiply by C. You say star. You do not just put C like this. Python will give you one invalid syntax. So you must put star multiplication, then plus 32, and you print your result. So I think this is straightforward enough. Okay. So you can take this example as classwork. Let P be a bank's interest rates in percent per year. An initial amount A has then grown to, so this is I think compound interest. After make a program for computing how much money 100,000 naira have grown 2 after 5 years with 10% interest rate. Wow, 100,000 naira. So let's see the result. That is 161,000 naira after 5 years. Okay, then this formula, Heron's formula as well. So you take all this as exercises or assignments. Okay, same thing with this. So make sure you practice them. Okay, cover. Do not look at the answers, the codes. Don't look at this code. You can cover the code. Try to write your own code to solve this before you look at the codes. Okay, so then yeah. So this equation 1.7, you must submit it. So this will be your assignment. Your assignment to submit. So the bell-shaped Gaussian function is one of the most widely used functions in science and technology. So the parameters m and s are prescribed real numbers. So make a program for evaluating this function with when m equals 0, s equals 2, and x equals 1. Okay, so you submit this. So you write a code to evaluate this equation 1.7, and you submit. Is that clear? All right. Well, if you have questions, so we can discuss them in the WhatsApp group, in our WhatsApp group. So if you have any question, okay. All right. So next is the Python comparison operators. So equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. So you want to compare two numbers. So we often need this when solving some physics problems. You want to compare two numbers or two variables. So you use this double equal sign for equal to. Okay, so for example, if I write 7 equals 8, this should be false because 7 is not equal to 8. But if I write 7 equals 7, then this will be true. If I write 7 greater than 8, so this is for greater than, so this will be false. Okay, but if I write 7 less than 8, then this will be true. And if I write 7 not equals to, okay, this is for equals to, equal, also equal. This is for greater than, okay, this is for less than, and this is for not equal, not equal, not equal. Okay, so 7 is not equal to 8. So this will be true because 7 is not equal to 8. But if I write 7 not equals to 7, then that will be what? That will be false. So 7 not equals to 9 is true. So 7 equals 8, 7 equals 7, true. So we have looked at equals to, greater than, less than, not equal to. Which one again? Greater than or equal to, less than or equal to. Now, where do we need this? Let me quickly think of an example of a way where we need this. So let's say we want to print, I want to check if a number is even or not. Okay, if a number is even, so let me say check if a number is even or odd. Okay, it's even or odd. So how do we check? So let's just take any number. So let's say x equals 56. So we now say if x percent 2. So this is the advantage of the percent sign. That is, if you divide x by 2 and the remainder is 0. Okay, for example, 8 divided by 2 is 4, remainder 0. So if the remainder, if x percent 2 equals 0, it means what? It means, so now say print the number is even. Okay, the number is what? Even. But if x percent 2 is not equal to 0, it means the number is not even. It means print the number is odd. The number is not even. So if you try this 56, if you run it, so you get the number is even. But if you run 59, you get the number is what? Odd. So this is, so here we have used the remainder sign symbol and the equals to symbol. Okay, so we are testing if x percent 2. You know, if you recall, our percent was remainder. Okay, remainder 27% 3. So it means 27 divided by 3 won the remainder. Okay, so that is it. So here we are checking. We are saying 59 divided by 2. Now, if 59 divided by 2, there will be a remainder, which is 1. And 1 is not equal to 0. So you have to know logic. So if you want to understand programming, so you need to understand logic. So let me explain the code again. You have a number and you want to test whether the number is even. So what you do is you find the remainder of the number by 2. So if you divide by 2, what is the remainder? So if the remainder is equal to 0, that is the essence of this equals. If the remainder is equal to 0, it means the number is even. But if the remainder is not equal to 0, it means the number is odd. Okay, so for this we can check if a number is even or odd. No matter how big the number is odd. So if you end it with 8, then the number will be what? Even. Okay, also we can check whether a number is greater than 45. Okay, want to check whether a number is greater than 45. Okay, so let's just take a number, x equals 49. So again, you say if x is greater than 45, then you say print the number is greater than 45. Then you close the bracket. It must be in a string. Okay, but if, so you can say L, if x is less than 45, then you print the number is less than 45. Okay, then you can say else, that is what can remain if the number is not greater than 45 and it is not less than 45. What could that be? Else, it means the number is 45 itself. Else print, the number is equal to 45. Okay, so if you run this 49, so we're going to get the number is greater than 45. Okay, but if you run 40, then we get the number is less than 45. And if you put 45, then we get the number is equal to 45. So we have learned two things here. We have learned how to use the greater than and less than operator, and we also learned how to use the if, elif, else operator. Okay, so even though if you are a beginner, we do not advise you to use this else, because sometimes you might not have captured all the possibilities. Okay, so we recommend that you still use elif. So elif x equals 45, then print the number is equal to 45. So I think you should hold on with the else. So but usually if you have captured all the possibilities, then remaining maybe one possibility. Okay, then you just say else, that is every other condition, you should print x equals 45. But for now, I will recommend, since you are beginners, to use elif. Okay, use the elif, but we'll get to the if statement properly later. Okay, all right. So lastly, the logic operators and then or. So if you say, we have looked at if you say 7 is greater than 4, this is true. Abi, this is true. But if you now combine them, 7 is greater than 4 and 5 is less than 8. 7 is greater than 4, this is true. 5 is less than 8, this is true. So this is going to print what? True. But if you say 7 is greater than 4 and 5 is less than 2, we know that 7 is greater than 4 is true, but 5 is less than 2, this is false. So the answer will be what? False. So because sometimes you need this as well. You need, instead of, in this case, we had just one condition, equals to and not equals to. Sometimes you may have two conditions, that you need to put and. But in some cases, you need to put or, that is to satisfy only one condition. Let's look at the first case, and. So, if the and will return true if the two conditions are satisfied. If this is true and this is true, that is when this and will return true. Again, this is logic. Maths 203 set logic. Okay, this is logic. So you need to understand a bit of logic. So, but if I write, so this is false because 5 is not less than 2. 5 less than 2 is false. 7 greater than 4 is true. So if you are using and, for you to get true, the two conditions must be true. Okay, so if you need the two conditions to be true, then you use and. But if you need just one condition out of two conditions to be true, for example, you need maybe z greater than 4 or 5 less than 2. So if you need only one of these two, that is when you use or. That is either this is true or this is true. So it will return what? True. But if the two are false, then it will return false. So you use and if you want the two, if the two conditions, you want the two conditions to be true. But you use or if you want only one of the conditions to be what? To be true. And it's not restricted to just two conditions. So I can show you some of the codes I wrote. Let me see if I can quickly access them here. Okay, so this is an example. So if RP equals 1 or RP equals 3 or RP equals 5 and so on. So just only one of the conditions, not all of them. If it satisfies only one of these conditions. Else, if the okay, so it's not restricted to just two comparison operators. So you can extend it as many as you want. Okay. So you can say 5. So you can say or 3 less than 9. So this will return true because this is false. This is false, but this is true. Okay. So it requires only one of them to be true. Then it will proceed. So probably in the course of the lectures, the other classes, so we'll learn how to use this as well. I mean the application in physics. All right, so this is where we stop today. So this is an assignment. Oh, the code is already written, but please don't look at the code. Okay, just try to write your own code to evaluate this before you look at the answer. Okay, so this is very, very important. All right, so I'll see you in the next class. Bye bye.